I'm Andrew Levine, the CEO of Koinos Group, and welcome to the Koinos Group podcast. At Koinos Group, we're developing the Koinos Blockchain, which will have free transfers, free accounts, and free smart contracts. These features, in combination with a number of technical innovations, will make Koinos the first programmable blockchain with no barriers to entry. And as a result, we expect it to touch every corner of the technology space. So we'll be using this podcast to share information about the project, interview members of the team, and interview people from other projects, not just in the blockchain space, but in the tech space more generally, because we're building Koinos to add value to any project, not just projects that want to build themselves as decentralized or blockchain powered. In today's episode, I'll be interviewing one of my co-founders, Nathaniel Caldwell, who's also one of the architects of the Koinos blockchain. Unlike most other projects, we have not one or two, but four amazing blockchain architects with unrivaled experience building, maintaining, and upgrading high-performance blockchains. In this episode, Nathan is going to tell us a little about his background and then explain one of the important technical innovations that he's worked on called Koinos-Types. At Koinos Group, we are developer obsessed, which means that we want to build tools that developers love using to build amazing blockchain-based applications. That's why we think it's super important for Koinos to have multi-language support. It should be fast and easy to create amazing client libraries, microservices, and smart contracts in the programming languages developers already know and love, and it should also be just as easy to update them. Koinos-Types is key to accomplishing that goal. So without further ado, hey Nathan, can you tell us about your background and how you came to be working on Koinos?
Got interested in programming when I was a little kid. I wanted to make video games, and that sort of was an on-ramp to learning about the wonders of computer science in general. And I was in high school. I was learning C++ and playing around with it. And by the time I got to college and had to make a choice on what I wanted to study, I was very interested in physics simulation, and so I actually went for physics and not computer science, to learn those skills. And so my undergraduate degree was in physics, and then a master's in computer science. Following that, I actually worked in nuclear physics when I was in academia, when I was studying. And then I left academia to go to the private sector and work for government contractors. I ended up, with my science computing background then, I ended up in biometrics doing fingerprinting and iris scanning solutions. And from there, I ended up in DNA forensics, writing software for crime labs. And it was around that time when I was in forensics that I was really starting to get interested in the blockchain technology. It was sort of emerging, at the time. I was in forensics for a while. It was emerging at the time. I got kind of involved in Litecoin mining and learning about the technology, and I saw it as an answer to a lot of problems that the world was having. I think it really interested me because decentralization of financial technology was really something that I'd been thinking about, but didn't have I didn't have an answer to it, at the time, but some very smart people did. And so I got very interested in studying that and realizing some of the larger problems it could solve, especially when smart contracts came to the forefront with Ethereum. And so I was very interested in that, and especially since I was working as a government contractor in things like biometrics and crime labs. I sort of got a front row view to some of the just waste and corruption going on, and it really sort of struck home. for me. That's not not the right term. It's sort of it really sort of it was the right thing at the right time. It was the right technology at the right time. I thought, and so I ended up actually getting an interview at Steemit, and so they moved me to the main Steemit blockchain team, and I was going to be a developer on that team at first, but then there was a management vacuum, and they thought I was the right person to fill it, and so I ended up as the product manager of the blockchain team, and so that was different. It was new to me. It was really good experience, and I learned a lot about another side of development there, and I learned a lot about blockchain, of course, which is it was like a dream to me.
Now let's talk about Koinos-Types. It was pretty hard for me to wrap my mind around this. Can you explain Koinos-Types and why they're such an important part of our solution? What's the deal with Koinos-Types?
The deal is a problem that we discovered, with our experience in implementing blockchains is there are the protocols that you have to talk to, the blockchain monolithic or microservices, whatever the case is. You have to have an API. You have to, have your program somehow, your client library, your service, whatever you're writing, you have to have it be able to communicate. And there are certain objects, complex objects, that you simply need to have exactly the same bit for bit, or else, I mean, we're doing signature verification. We're doing all kinds of finicky things with the blockchain that you need every bit to be correct. Every bit needs to be in its place in the same order. And that turns out that can be a screaming pain. If you're trying to write a Python library to talk to the Steem blockchain, like we have experience with, you are re-implementing the serialization. You're implementing all of the types, exactly the same way, so that you have the same representations and the same messages. And that's it's difficult, it's error prone, it's time consuming. And you're doing this for every language, and every application developer practically has to do this themselves before they can even start to do whatever they're trying to do. Assuming they're doing anything that's beyond trivial, you're just doing this. And so we wanted a way to represent the same objects across different applications and in different languages. And we looked at existing technologies. There are technologies that do this. Protobufs, comes to mind. That's a major one, Google's Protobufs. But there was really nothing that we found that quite served our needs. Protobufs, for instance, doesn't guarantee the same representation across different languages or even versions, I believe, of protobufs. So you're going to communicate the same objects in the end, but the bit ordering of the serialized, when you convert it to bits, it's not necessarily going to be in the same order, which is, of course, incredibly important for a blockchain, for signatures and everything. So we couldn't use that. It didn't quite suit our needs. Close, but no cigar. And so we wrote our own solution to this. And that is, we've called it Koinos-Types. And essentially what it is, it's a definition language. We have a definition language in which you define the types that you want, the various objects, a block, a transaction, the different API requests and responses. You define what these look like, what data they hold. And then we have a compiler that compiles that definition language into an intermediate format that's then easy to convert to whatever language you want. And so we have done this for C++ and now Golang. You have native representations in the language with JSON and binary serialization that are the same across those platforms. We've designed it in such a way that adding new targets is it's significantly simpler than implementing it from the ground up in that new language. It's 10 times less work.
So let me try to explain this in terms I understand it, and then you tell me how I'm wrong. You have object-oriented programming languages like C++ and programming languages that don't have objects. And so you need this kind of translation layer that enables services or programs written in these different kinds of languages to understand one another.
So it's not the fact that different languages have different paradigms. It's that simply every language that you need a representation of a block. If I'm using Go, I need something that represents a block in the Koinos blockchain. And not only do I need a stand-in for a block that can hold all of the data of a block and act like a block, it needs to look like a block and act like a block does in every other language. They need to be equivalent, and that's the difficulty. You need to, for every language, you're writing the same thing that has to act exactly the same way, and that's finicky, difficult. Just because, not necessarily because that language has a different paradigm, but because you're just doing the work over and over again for every language. You're writing a lot of code and doing a lot of testing to make sure it all acts the same. We're offering a solution that simplifies that greatly. So it does a lot of that work. It does a lot of that work for you towards achieving that goal.
So my last question on Koinos-Types. It seems to me like Koinos-Types is a great example of one of these highly technical, seemingly small solutions that is actually a key component and explains why blockchains like EOS, like Polkadot, like Ethereum, still don't have multi-language support for their smart contracts, because this is the type of highly technical work that you have to do during the design phase of the blockchain in order to enable that functionality at a later time. Is that right?
Yeah, so Koinos-Types isn't exactly for smart contracts. It's for client libraries, and it is one of the reasons that that you get a lot of bugs and slow development in client libraries, especially when so if I'm interacting with Ethereum, I'm probably using JavaScript because there's so much tooling and all of the types are represented simply. And if I'm going into Python, there's some support written in Python, but that has to be maintained separately. It has to be, a whole lot of work needs to be done to create and maintain the code that I need in Python to talk to Ethereum. Go libraries for Ethereum, same thing. Someone has to do a lot of work and maintenance just to get and keep those libraries running as things change. This this not only allows you to easily begin targeting a new language for a client library for a software that interacts with the blockchain, but it also makes maintenance a lot easier. You're not, there's a pretty good chance that things will, change as time goes on. Of course, types will evolve, and now instead of having to pull your hair out and panic and write a whole bunch of new code to figure out what's going on and support it, you will download the latest version of the object definitions. smack compile on it, and you'll have the new types and the way they work represented, with potentially minimal work having to be done to retarget that. My part in Koinos-Types was pioneering targeting new languages. We wrote it at first only outputting C++, using a lot of C++ isms, and not not sure yet what work would need to be done to be able to support other languages. And I added Golang support and did the work required to make sure that that it's simple to add support for new languages going forward. We have a compiler that looks at the definition language and takes those types and breaks them down into sort of a graph of what every type, what kind of data it holds, what other types it depends on. You sort of have a tree of dependencies, like a block holds a transaction that you have things referencing each other. So this sort of breaks it down into an easily readable, parsable map of what you're looking at. And then the way we turn that into, the way we target that for a new language is we parse that we use a macro language called Jinja, which is interestingly designed to be a web template, designed for writing out HTML, actually, but we are using it. But it turns out it's a really good multi-purpose language for just taking code and writing other code. And so we produced Jinja templates for each language that parses this map, and then what you do if you're writing a new target, then we have a bunch of macros that you can sort of copy paste and replace that you'll make it output representations that make sense in that language. And then when you run the compiler targeting that language, then you'll get your code that you can then use. It is sort of written in an object-oriented paradigm, so anything that even pseudo supports objects will be simpler. Writing it in Haskell would probably be a pain in the butt. Basics, some crazy languages would be, but most modern languages, Python, JavaScript, they'll be simple to target. They'll probably be simpler than Golang. Golang itself is kind of an odd duck with its very minimalist feature set. It was really strange the way that we had to implement some of the ideas in the macro. So many other languages will be a lot simpler than what we've already done. Most I would say that people would want to use.
Is this the kind of thing where the work you've already done is useful in future work? So if you're trying to add support for a new language and it already supports a similar language, it'll be less work?
Absolutely, yeah. I would just, if I were implementing a new language, which most likely will be, I would take that template for Go that we wrote, copy it, and start from there. Copy and just start, replacing pieces with. Chances are it's going to, if not completely, usable with the macros that we defined, very close with minimal, we'll say wild changes to it. You'll be more or less converting what we've written there to the language that you're targeting, which is not terribly difficult in most modern languages.
It was almost like working out, where like you make the challenge really hard for yourself, but you actually create like a more robust solution.
Yeah, I think that's probably fair. Yeah, Go, like I said, Go is a little odd. It's missing some things that a lot of languages have. There's no way to do templates and or generics. If you know if you're familiar with that, it basically means you're writing a lot of code over that does the same thing. It doesn't have uh, enums. It doesn't have, there are a lot of strange things that are more difficult to implement. I'll put it that way. There are a lot of strange things that are more difficult to implement. And by doing that first, it certainly a lot of other languages that we want to target will be, now that that work's done, will be easier. Like working out and then, oh, now I have to lift a pencil. Sure.